right, let's take a look at Chapter 3, Section 3.4, Verifying Arguments. Use the truth table to show an argument to be valid. Use truth tables to verify arguments. Recognize some common valid argument forms. Recognize some common fallacies. Verifying arguments. An argument is a series of statements called premises, followed by a single statement called the conclusion. An argument is valid if, whenever all premises are true, then the conclusion must also be true. Representations of arguments. The first representation is symbolically. The second is in statement form. And the third is in statement symbol form. Okay, so the first symbolic form of the argument reads, if P then Q, P, therefore Q. Where the first two rows are our premises, the first two statements are our premises, and the conclusion is the statement Q. It reads, and is true or valid if the first premise is true and the second premise is true, then the conclusion is true. When we fill out a truth table, we will look at the and between our premise statements and the implication between our premises and the conclusion, the if-then statement. Notice between each grouping of information, there's a two-way arrow, which means if and only if. Verifying arguments. Step 1, make a truth table with separate columns for each premise and the conclusion. Examine only the lines in the table in which all the premises are true. If the conclusion is also true for the lines you examined in step 2, the argument is valid. If the conclusion is false for even one of the lines you examined in step 2, then the argument is invalid. Example, determining the validity of an argument. Determine whether the following argument is valid. If you buy the more expensive Hulu plan, then you can watch TV commercial free. You cannot watch TV commercial free. Therefore, you did not buy the more expensive Hulu plan. Solution. Let E stand for the statement, you buy the more expensive Hulu plan. And let F represent the statement, you can watch TV commercial free. Then this argument has the following form. If E, then F, not F, therefore not E. Determining the validity of an argument continued. Now we make a truth table for this argument. Here we have E, the statement E, then the statement F. The statement E is TTFF. The statement F is TFTF. From there, we look at premise number 1. Premise number 1 was if E, then F. Premise number 2 was not F. And the conclusion was E. So this is mod F. This is not E. And our argument read E, if E, then F, not F. Therefore, not E. All right. Now, I generally make some type of distinction for myself, at least, so that I know when I'm looking at the premises and when I'm looking at the conclusion. Now, because the only line in which both premises are true also has a true conclusion, we conclude that this argument is valid. Some invalid arguments. Determine whether the following argument is valid. We've been told it's not. So if I have the new if I have the new calling plan, then I can text my friends for free. I can text my friends for free. Therefore, I have the new calling plan. Solution. If we let C represent I have the new calling plan and let F represent I can text my friends for free, then we can write the argument symbolically as if C then F, F, therefore C. We will make a truth table as we did in a previous example with columns for both premises and the conclusion. Here they list C first, then F by convention. C is TT, FF. F is TF, TF. Then we have premise 1, premise 2, and the conclusion. When both premises are true, the conclusion is false. So we'll have an invalid argument. Line 3 in the table shows that it is possible for both premises to be true, but the conclusion is false. This means the argument is invalid. Here we have 4 forms of known valid arguments and 2 forms of known invalid arguments. We have the law of detachment, which says if P, then Q, we have P, therefore we have Q. The law of contraposition says if P, then Q, we don't have Q, therefore we don't have P. Law of syllogism reads if P implies Q and Q implies R, then P implies R. Disjunctive syllogism reads P or Q. We either have P or Q. We don't have P, therefore we have Q. And the 2 known invalid arguments are the fallacy of the converse and the fallacy of the inverse. It is a fallacy to think that if P then Q, we have Q, therefore we have P. That's wrong. That's a wrong way of thinking. Also, it's a fallacy to think if P then Q, we don't have P, therefore we don't have Q. That is also a fallacy, an invalid way of thinking. Identify the form of an argument. Identify the form of each argument and state whether it's and it's valid or invalid. If you want to improve your cardiovascular fitness, then take up cross-country skiing. You take up cross-country skiing, therefore, you want to improve your cardiovascular fitness. Let I represent if you want to improve your cardiovascular fitness, and let C represent you take up cross-country skiing. This argument has the following form. If I, then C, therefore I. If I implies C and we have C, then we must have I. This is the fallacy of the converse, which is an invalid argument form. If you sleep through your morning math class, then you will be well rested. If you are well rested, then you will do well on your math test. Therefore, if you sleep through your morning math class, then you will do well on your math test. Let S represent you sleep through your morning math class. Let R represent you will be well rested. And let W represent you will do well on your math test. Then the argument then has the following form. If S, then R. If R, then W. Therefore, if S, then W. This is a syllogism and is therefore valid, even though the reasoning seems to make no sense.